Good day, everyone. My name is Hazel Asmetra. My topic is all about measure of position, quartiles, z-scores, percentile, and box and whisker plot. So we're going to learn how to determine the quarters of dataset, determine that in quartiles, range of a dataset, create a pose of whisker plots, interpret other factors such as a percent also, determine in interrespect the stand scores, which we know with the record I discussed now, determine the quarters of the dataset. In the quarters, this hand the values that we determine or such opportunity to learn measures of position of the virus, so such as measuring the central tendency we find as a medium move to see how data is a values of the data discussion of data. We will define range of variables, also that standard deviations. Now you want to measure the position of the values like 25 positions, what kind of balloon rated of less than the middle of 50% or and 75% or in a position day. Here we can use the percentiles or we will use quartiles, with this that means for parts of the Q1, Q2, again Q3 also. Pose we will stick front visual we will can see the measure of the position value also. So let's start the with divisions, which is factors to. So here we send factors are numbers that partition divide as order a data into the equal parts. So there are letters to the quarters. So quarters is a practice because practice or data that again divided at least the data how to name is order as you have to name early stop increasing order. So practice numbers the quotations and other data sets into equal parts. So the mean of equal to quota means 4, so this means quotas safe practice but divided into 4 parts. So you will say of quotas approximative divided at other dataset into the equal to parts. So you go to truth each one each without the Q1, which is the first quota, such a quota will be 25%. So the first is 5% of the values are they greater than 60 or less than 60. So about 1/4 of the data for or below 1Q. Then second quarter is Q2, which is the middle of the Dan variable or the position, the middle position. So we can see that second quarters it's not the same as the main. Or remembering the main we will add the value divided by the number value, but to look for the second quarters, first of all data as have been softened, then the look for middle values. So Q2 and of the second quarter is the same or middle that sum as a median length. We will also find third quarters, which is the Q3, which about the 75% positions at 3/4 of that data for. So we have a sample here. Yeah, we have a test scores for 5 employees at run is a CPR training course. Yes, they are listening to below the test scores it a 15. We will said now here the sessions find the first, second, and also the third quarters of the date of a data set or the test score that we can look at these of data. We can see that are suffered from the 21 to 7, 10, 11, so is not softened. You have the difference of increase or other, which means the lowest value group. Or before the here's higher to have, here we can see that data is softened. Now 7, 5, 7, 8, 9, 15, 11, so on order to 15. So if it's 15, remember how we find their median when total value is hat number 15 is of hat number. We are going to get one middle of even numbers, get the middle value. So here we have a 6 is 15, 7 values of the left, 7 values of the right, so the middle of value is 15, and that we have give us or Q2. So the next we will need to find our Q1. So we can use the equal how went to the left side, and we will going to left side. We will look for middle value. That middle value is on left side was 10. Q1 that lower half. When we go into upper half, he also the battle 4 7. He was lot of mama's lower values is again 80 now. In the same test books, what we would normally to have a 15 to the left, and also hand a 15 have lower part of the right and left by. This is the test book again. We read especially. So here we say that but 1/4 of the products of 10 less of which is a Q1, 10 or less of 25, 1/4, and about 1/2 is for that 15 or less of a 1/2 to is the middle of 15. Then we say 75% of the studied score, 18 of less score. In 18, so this is a Q1, Q2, Q3 now. The reason why is the middle because of the value is the 15 or number say that the middle value is also shown. We can only want to the 15, then we will look at here first of the all the data must be soft. So we're going to lower half of the left. We'll look for the middle value. We're going to upper half, and also we will look for middle of the half. So next we're going to talk about the interested range. Interested range is the difference between 1Q and 1Q3. So the formula will be Q3 minus Q1. So the quartile range is a Q1 minus Q1 is normal. Again, so we use a lot of when we go looking to for outline. We will going data set giving. So we are using the first example. Going to again, we will also to that U11 to be 110. Talking at less example here, Q1 was then Q2 was a 15, Q3 is was 18. Now if they have said they should find the 80 quartile, we will data set which will be 18 minus 10 of a Q3 minus a Q1, and that's what we call the half here. So we have 18 minus 10, 2, 3 minus Q1, and 1 going is 8. So next we plot the box and whiskey plot. So here I say what highest the important features of datasets and need to require 5 normal summary. So need a minimal entry. Few 1, few Q2, Q3, and also the minimum extra. So yeah, that is things that you find a 5 summary affair of a data set. Then we will control horizontal scale that span that range of the data, and so then project 5 numbers of brothers of scales. An example of the here the first look I look data test at let's say from 10 to 100, so I can have summarized line scale is it from then 200 to 5 to 105 to leave the little the space to soft voice. So the minimum value is a beginning that much people will be an end. Then we have Q1, Q2, Q3. Remember even before find Q1 or Q2, Q3 we have to show the data so that it is in a certain order. So Q1 always will be less than Q also is less than Q3. That's all. Then the maximum value. Then we draw a box so that the middle box again in the Q2 which is the media. Then starting Q1 then which is the media and starting the Q1. Then so let's do that example the same problem again. Remember we will find at Q1 to Q10 UN to be to 15, you find Q2, Q3 to be 18. When we look at the questions, the data set then started from the 10, so 27, so which is a maximum values. We are so the match of values we use 37. So here are data minutes minimize the 5 much more than 37. Q2 was a 15, Q3 was an 18, Q1's with them, so we have a lot of 5 values, and we can again plot you or the bust of whisker plot. And so there would be start from 5 to 37, and so 5 the minimum, 37 and maximum, we draw the line. So then we have a Q1, the showbiz first starting of the box, the Q2 so is the line inside the box, then Q3 will be the head of the box. So we shall be use a box 4, so this surface against with the position of value. So I said 75% of the data for the 18, or only 25% for at 10, or so we also can find percentiles and also other factors. So it can be here 5 for 6 equal divided like Assad gas with his 22 in coverage. So here we have a Kyotas means only 4. So divided 10 into the 4 equal parts. So that Q1, Q2, Q3 that sound means a 10. So divided the tag to the equal parts. So you get D1 to the D9. Wrong was we don't want to say that the loss of Kiefer will be like loss of validity. Then we will have loss which is equal. Ready to know has the only code equal for part 2. What you go to kill then the center means 100. So that suffered I 299 P1 P2 P3 of the P90. So an example I give me here, we're going to interested of percentiles. So job graph given to us as they have say graph percentage of cost calculate or equality distribute for score or college to find structure in a serent of use a test score precedent of 7th access and how should you interpret this. So here I look at it. Look at the graph of 72 and percent is the sum where we have and that we give to somewhere like 1050 something we, so that we go to set 70 percentage based on the graph in somewhere around 1700. I get upward or half a line, so 72%. Go to way to 1700, so that means that we're members, and 72% of each 72% of the student has a SAT scores not 1700 watt left, so or less, because from 600 to 1700, and that 72% this is our percent of vertical line. This is vertical means again 72% of the student have a SAT score of 1700 or less, and or one more time we can go through one more. So we have a graph given to us, and the questions based on the guide of a data set that scroll a SAT, which is a horizontal line, and the percent of student to score. Then I show. So for example, I drew the line from 30 down to here. This means 30% of the students score someone or 1,300 or less. As this, the questions is what the score precedent 72 scientifically. The person is someone here, and we draw it down. We find to become 1,700, and that's what we have this line was 72,700. So that the question what this means, this means that 72% of the students scored 1,700 or less. So next go to a standard score against understand is also called a discuss. This column represent a number standard divisions at giving value as for from the means. We maybe discuss this in more details when I study the more the divisions, where we have a one standard divisions is 68 point, he went standard deviation at given person and the rest standard deviation of very division is the 99.7 when sent so is a present no more standard deviation. Normally we discuss the trade 1 2 3 given value for domains. Normally standard score for the normal distributions. The means will be the middle as the symmetry. Now, we find this also is the value of the x6 or looking for means the means of the data set divided by the standard deviation of the data set will x minus of a standard deviation. So the question is given this same 2007 for us we take up at the best truth of cast. Age 45 for girls in the movie. The last is Kasla. Is every the road the best asterisk of Casa. That's all. Thank you.
Is the topic for our group, exploring measures of association or correlation analysis and linear regression. What is the purpose of correlation analysis? In correlation analysis, the purpose is to measure the strength or the closeness of the relationship between the variables. In other words, we would like to know how strong or weak is the relationship existing between the two variables. The two variables associated in a statistical sense do not guarantee the existence of a causal relationship. The magnitude of association is measured by the absolute of R, which can range from 0.00 to 1.00. The greater the absolute value of R, the stronger the relationship between the two variables. What are the two variables? We have independent variable and the dependent variable. X variable is a predictor variable and the Y variable is a criterion variable. A correlation is a relationship between two statistical variables. We only consider linear correlation, which comes in the three types: positive linear correlation, negative linear correlation, and the zero linear correlation. The positive linear correlation indicates the high values for one variable tend to respond to high variable for the second variable or simply if one variable increases. Example, the height versus the weight. It increases for a normal individual and the weight also. Negative linear correlation indicate the high values for one variable tend to correspond the low variable for the second variable. For example, the vehicle are acquiring a vehicle and the resale price. As the vehicle gets older, the resale price becomes lower. Zero linear correlation. It means no linear relationship the existence between the variables. The example of this is the height and the number of years education. The height of the person in no way has a bearing on the number of years he had been in school. Thus, simple correlation. This is the independent variable is used to predict a dependent variable if there is a correlation between the two variables. And the scatter plot. Scatter plot shows if there are linear correlation between the two variables. There is three different types of linear correlation. The first one is to positive linear correlation, means general trend in the plot points is from bottom left to top right. The negative linear correlation is plotted points from top left to bottom right. The no linear correlation It is a no general trend and plot points or a linear trend.
Good morning, Sir Edgar. I'm Muhammad Hassan Halujalani. Today, I'm gonna discuss about measure of central tendency. We have mean, median, mode, weight, and mean. Mean is average. Ang gagawin natin para makuha ang mean, i-add natin lahat ng numbers at i-divide kung ilang numbers natin sa 5. I-add natin 4 plus 3 equals 7. 7 plus 5 equals 12. 12 plus 8 equals 20. 20 plus 3 is 23. And 20 plus 7 is 30. And 30 plus 9 is 39. And 39 plus 1 is 40. In this case, ang number data natin is 8. Then, divide natin siya 40. 40 divided by 8 is equals to 5. So, ang mean natin is yung 5. Median. That is the middle value of ordered data. Ang kailangan natin, i-arrange ang pinakamaliit hanggang sa pinakamalaki. We have 1, 3, 3, 4, 5, 7, 8, 9. And then, kukunin natin yung pinaka-middle. 1, 2, 3, 7, 8, 9. And that is 45. Ang gagawin natin, since dalawa sila, i-add natin at i-divide sa 2. So, 4 plus 5 equals to 9. Divided by 2 over. So, ang ating median is 4.5. Mode, the most frequent value. Ano sa ating data ang mas marami ang lumalabas? So, kikita natin is number 3. So, our mode is number 3. Range. Range is the difference between highest and lowest. So, our highest data is 9 and the lowest is 1. So, 9 minus 1 is 8. So, our 8 is the range. And that's all about my topic about measure of central tendency. Thank you.
Hello there, welcome. Good day to each number one. I discussed to you about the measure of dispersion, range, variance, and standard deviation. Firstly, what is the measure of dispersion? A statistical concept that helps us to understand spread and variability of data. It helps analyze so much weight from the central tendency. Common measure of dispersion include range, variance, standard deviation, and also understanding this measure is crucial for interpreting and comparing datasets. What is a range? The range is the simplest measure of dispersion and represents the difference of the highest value and the lowest value in the dataset. For example, in the dataset of the score is ranging from 60 to 90, the range is 30. For the formula of the range is equals to highest value is the minus the lowest value. The highest value is 90, lowest value is 60, minus it, the range is 30. This is a formula of variance. There are two, population and sample. I have an example of sample variance here. The problem is find the variance of the following set of data 321, 98, 203, 70, 90. First thing to do, we need the mean formula. X mean equals to the summation of x equal over n. Second, we need to add this set of data. 3 plus 21 plus 98 plus 203 plus 17 plus 9 equals to 351. Third step, we need to divide it 3, 5, 1, and we need to find the end. And find the end, we need to count this set of data 1, 2, 3, 4, 5, 6, and divide it or the mean is 58.5. That is our mean. Now we can make a table. X 3, 3, 21, 21, 98, 203, 17, and 9. Then mean minus item of the number set is minus the mean. To get this second column, we need to minus 58.5 minus 3. But we can get 55.5. Repeat the process. We can get here 37.5, 39.5, 144.5, negative 41.5, 90, 49.5. Now, parentheses, x, the mean, and the square. To get this third column, we need to square it here. This value. 55.5 squared equals to 3080.25. Repeat the process again. 1406.25, 1560,000, 25, 20,880.25, 1722.25, 2,450.25. Now, we done in our table. This is our table. The summation of item of set data, then the x mean squared. To get this, let's add it here to get the total. The total is 31,099.50. Now, we need the sample variance formula. S squared equals to summation of x equals minus mean squared over n minus 1. Now, substitute the value. 31,099.50. Substitute again. 6 minus 1 is 2. 31,999.50. 6 minus 1 equals 5. Now let's divide it. Sum equals to 6,219.9. That is the sample variance. Sample variance. Standard deviation. I have an example of standard deviation. Here's sample variance for group data. Compute variance of the test score. The score is 22 to 24, 19 to 21, 16 to 18, 13 to 15, 10 to 12, frequency 5, 6, 7, 8, and 4. As you can see, we have the class mark here. Class mark, we can get the class mark by calculating these scores. 22 plus 24 over 2. Add 24 plus 22 plus 24 equals 546 divided by 2 equals to 23. We have the 23 plus mark in the first example. Scores. Repeat the process. And we can get here 20. Third one, 17. Fourth, 14. And 11. Now next, the F frequency, parentheses, the class mark. To get the class mark, you need to multiply frequency and class mark. 5 times 23 equals to 115. Also repeat the process again. 115. Second, 120. The third one is 119. 112 and 44. Next, mean. To get the mean, we need the total of the frequency. Frequency equals to n equals to 30. And I forgot. The formula of the sample variance of our group data is sample variance equals to summation of frequency, open parentheses, class mark or midpoint minus the mean squared over n1. Now, the n is our frequency, the xm is class mark, the x is the mean squared. Now, we have the n is 30. Now, we add this column to get the summation of x frequency and xm equals to 5, 10. Now, next is the mean. To get the mean, we need to formula x equals to the frequency m divided by the frequency. Now, substitution, mean equals 5, 10 minus the 30 equals to 17. Now this mean is 17, our mean. This is our mean. Now we have the xm minus mean. To get this xm minus the mean, 6 won't. Let's minus plus mark and the mean. Equals to 6 first, and 3, 0, 0, 0. And here negative 3, negative 6. Next, we have the xm plus mark equals to the mean squared. The seventh column is xm plus mark minus the mean squared. To get this, we need to do squared. 6 is equals to 36. 3. 3 times 3 equals to 9. 0 times 0 equals to 0. Negative 3 times negative 3 equals to positive 9. Negative 6 times negative 6 equals to 36. The last one, we have the frequency class mark minus the mean squared. To get that, we need to times the frequency and the seventh one is 36. 5 times 36 equals to 180. Repeat the process again, then 54, 0, 72, and 144. Now, we had to total this to get the summation of a class mark or midpoint, the mean, and squared. Total of 450. Now, we can use this formula to calculate the sample variance. S2 is summation of F class mark and mean squared, n minus 1. Substitution tayo, 450, 29. Sample variance equals to 1 by 15, 152. That's all. This is the formula of standard deviation. In conclusion, in a summary, the measure of dispersion, such as range, variance, and standard deviation, provide essential insight into data variability.
Hello, this is Elham Alvarez from BSIT 1A, and I am assigned to report the topic of probabilities and normal distribution. What is probabilities and normal distribution? Normal distribution, also known as the Gaussian distribution, is a probability distribution that is symmetric about the mean, showing that data near the mean are more frequent in occurrence than data far from the mean. And this is the example of normal distribution. The height of people is an example of the normal distribution. Most of the people in a specific population are of average height. The number of people taller and shorter than the average height people is almost equal, and a very small number of people are either extremely tall or extremely short. Importance of probabilities and normal distribution. Number 1. It is the most important probability distribution in statistics because it accurately describes the distribution of values for many natural phenomena. Number 2. A probability distribution depicts the expected outcomes of possible values for a given data generating process. Probability distributions come in many shapes with different characteristics, as defined by the mean, standard deviation, skewness, and kurtosis. Number 3. One reason the normal distribution is important is that many psychological and educational variables are distributed approximately normally. How do you solve the probabilities of a normal distribution? To solve these types of problems, you simply need to work out each separate area under the standard normal distribution curve and then add the probabilities together. This will give you the total probability. The two types of probabilities and normal distribution. Number 1 is discrete probability distribution. A discrete probability distribution counts occurrences that have countable or finite outcomes. Discrete distribution contrasts with continuous distributions, where outcomes can fall anywhere on a continuum. Common examples of discrete distribution include the binomial, Paschen, and Bernoulli distributions. Number 2, continuous probability distribution. Continuous probability distributions, a probability distribution in which the random variable x can take on any value, is continuous because there are infinity values that x could assume. The probability of x taking on any one specific value is 0.
Identify the data point. B equals to y equals to ax. This is the third due to shows the B what are. The nation x represents the mean of the x values and y represents the mean of the y values. Next, section A is this is the sample solution. Our x is we created two data sets of data. Positive correlation. We start from x 2.5, 3.5, 3.3, 3.5, 3.8, 4.0, 4.2, 4.5. This is the sample 3 or 2 adding to our sample, and also y 3.4, 4.9, 5.5, 6.6, 7.0, 7.7, 8.3, 8.7. This is the random number that shows in the section. So this defined as called steps to one actual process and results. First, prepare the columns for x squared and xy. So this is the sample. 2.5 is square root of 2.5 is 6.25. So we created a one and combination of x and y. Is show the output or results this here. So summation x is equal to 28.8, which results overall only x and only y, only x squared and xy. So this is the second. Compute a slope. A is represent this section before a sample of for output for A. So n summation n is 8. We get the 8 in and summation of xy 95.86 and summation of x. So this output represent to solve a slope. So this is the result. A equals to 2.7303. So this is 2.7. The third is find the means of x, y, and and x and y values and the intercept b. So this is the x and summation x is 20.28 and n is default as 8 is equal to 3.6. So also y, so that this the result here b equals to y minus ax equals to 6.5 25 2.7303 3.6 equals to negative 3.31. So this is the b intercept of b. So this fourth round a and b to the nearest tenth and find y. So this here is firstly as greater a 2.7 b 3 negative 3.3. The least square is y.
Good day, sir. I'm Crisol Lopez from BSN Type 1A, and I'm reporting about the gathering data. So, unlock the power of data and understanding the process of gathering data using graph and chart. So, data gathering is the process of collecting information or facts. So, better understand a topic. So, it involves like it's the structure approach. Structure approach adapts systematically. A systematic and well-defined process and secure, accurate, and comprehensive collection. So structured approach to data gathering involves analysis and this is the multiple source, explore varied channel, such as understanding of the object. So referencing data from diverse sources helps validate finding and reduces bias. So data gathering the collected information in accurate, reliable, and conforms to predefined understands. So it involves checking for errors, consistencies, or outliers in data is crucial for making informed decisions based on reliable information. So also the quantitative and it deals with numbers and measurements, answering how much or how many, while the qualitative focuses on qualities, descriptions, and information in a clear and organized way, making it easier to understand and analyze. Data cleaning fixes errors, while data verification confirms accuracy for reliable information. So that's all for things.